Good day, my highly esteemed viewers. You're welcome back to class. As you already know, my name still remains Israel. Today, we are going to be talking about how to calculate very simple method of calculating molecular masses. Let's see how it goes. So like I said, we are going to be having a look at a very simple method of calculating molecular masses of some compounds. Now, molecular mass of compounds is the sum of its individual atomic masses. You just calculate, you just take they normally give the atomic masses. You just gather them, take them together, sum it up. What it gives you is the molecular mass. Let's say, for example, calculate the molecular mass of calcium triisocarbonate 4. Ca equals 40, C equals 12, O equals 16. To carry out this, the same process, the same method. You see solution. CaCO3. Calcium here is 40, you are told. That's the mass number. 40 plus 12 plus 16 times 3. 40 plus 12 plus 48. Let's see how it goes. Without calculator, let's see how it goes. 12, 48. This gives 60, 100. So it's 100 gram per mole. So that is the molecular mass of, or molar mass of calcium triisocarbonate 4. So molecular mass is 100 gram per mole. So this one we're going to throw about three examples. So let's have a look at another. Assuming you are told to calculate the molecular mass of Na2CO3. This is sodium triisocarbonate 4 with Na giving us 23, C giving us 12, O giving us 16. See, the same method you use, same processes. You say solution. Na is 23, let me write it out. Na2CO3. 23 times 2. The first one would have multiplied, but it's all 1. Times 2 plus 12. There is 1 here times 1, if you like. But usually 12 times 1 is 12, so no need. Because it's only 1 you have here. It's only 1 that is here. Carbon is 1. No need to multiply by 1. You just say plus 12 plus 16 times 3. 16 times 3 because it's more than 1. Multiply by 2 because it's more than 1. Remember, between the two elements, you put addition sign. So this is 23 plus 12 plus 48. You add them. 23, 12, 48. You have 10, 13. This is not 23. This is 46. Sorry for that. 46. So this one gives you 6, 8, 9, 10. 106 gram per mole. So that's the molecular mass of sodium triisocarbonate 4. Subsequent videos I will give, I'll teach you how to name it, how you name this compound using IUPAC nomenclature. Because in this part of the world, Nigeria, we normally use the IUPAC system. Though there are some countries, they don't follow the IUPAC system. They still follow the old pattern of naming, like this sodium carbonate. That's what they will call it. H2SO4 sulfuric acid, that's what they call it. And some of the products we buy from such countries, we still have it because they were not part of the countries that decide on the IUPAC method of naming compounds. So like H2SO4 now is tetrazosulfuric acid based on the IUPAC system of nomenclature. Then this is sodium triisocarbonate 4. Subsequent video, I'll teach you how to name them. Since all our exams in Nigeria, you follow the IUPAC system. Follow the old system, they'll mark it wrong. So we have this. Let's do the last one and see how it goes. Let's say we have NH4 H2SO4. It's too far. SO4. So this ammonium tetraoxosulfate 6. Ammonium tetraoxosulfate 6. Let's calculate the molecular mass. Remember we said molecular mass is the sum of each individual atomic mass or mass number of each of them. So you have nitrogen. To make it simpler, you can do it within the bracket, but always try to make it simpler. This one is the molecular formula. You can break it into empirical formula. So you multiply this one to remove the bracket. This is N2 plus N2H8SO4. This one is empirical formula of it. So you have this one. You have your nitrogen. It will tell you N is 14, H is 1, S is 32, O is 16. So we say solution. Let's try it again. This one makes it clearer so that you have the question. SO4. Like I said, remove the bracket. N2H8SO4. So N is 14. 14 times 2 plus 8 times 1. Remember hydrogen is 1. Plus 32. Nothing to times with it. Plus just 1. Plus 16 times 4. So let's see. This is 28 plus 8 plus 32 plus 64. I think so. So let's add it. 28, 8, 32, 64. Now this is 16, 20, 22. 8 plus 8 is 16. Plus 2 plus 4 is 20 plus 2, 22. 6 plus 5, 11, 12, 13. 132 gram per mole. This is a very simple method of calculating molecular masses. It has a unit, solely the relative relative molecular mass that doesn't have unit, because the various elements from which it was calculated, they don't have unit. Also, relative atomic masses have no unit, except even though they normally say AMU, atomic mass, that's not actually a unit. So this is how you calculate the molecular masses of some compounds. Dearly beloved, please, as I told you all the time, when you are carrying out these calculations, get a note and try to copy the questions and copy the solving. It will do you good. Kindly share this video and also subscribe. God bless you.